This lesson is 9.3. This lesson is on polar and rectangular forms, which we've sort of touched on before. We've talked about a little bit in the past, so this should be mostly review. We can switch between rectangular and polar forms by understanding the relationship we have between x, y, theta, and r. So I've included a triangle here. We say that the base of our triangle is x, the height of our triangle is y, the hypotenuse of our triangle, or what we talked about in vectors, our magnitude, this distance from the origin to that point xy, that value is r. And then we have this theta over here. That's our reference angle, essentially. So we have r, theta, x, and y, and we're going to talk about how these are related. So we can come up with our value of r x squared plus r squared. Therefore, r equals the square root of x squared plus y squared. We know that. That's just the Pythagorean theorem. If we wanted to come up with theta, we would look at inverse tangent if we were given our r and our theta and we wanted to come up with x and y, all we would do is r cosine theta equals x, which you can derive from this triangle. If you were looking at cosine of theta, you would get x over r, and then you would just multiply by the r. So r cosine theta equals x. And we would look the same way at r sine theta is equal to y. So this is how we can come up with all of our different values. This is how they're related. And tan inverse equals theta. And you can just do the x squared plus y squared equals r squared also. So let's look at an example. It says find the rectangular coordinates for each point with the given polar coordinates. So we're starting with polar, we're starting with r and theta, and we're asked to find x and y. So for this example, we have r equal to 4 and theta equals pi over 6. So to find the rectangular coordinates, this x and this y, we need to find out what x is and what y is. So we have x is equal to r cosine theta. That's the first place to start. We can plug in those values. So we have r is 4 cosine of pi over 6. And we can solve that. So we have cosine of pi over 6. Where is that? Let's look at our unit circle. That's here. That's where we have our biggest drop down, right? So that means we have really 4 times rad 3 over 2. And this would just end up becoming 2 rad 3. That's our x value. Now let's look at sine. So for our y value, we would want to do r sine of theta. That's our basic place to start. Y equals r sine theta. We can plug in our values, 4 for our r and sine of pi over 6. Now again, here at pi over 6, we have the smallest y value, so that's actually going to be our 1/2. So we have 4 times 1/2, which is just equal to 2. So if we want to plug that into our coordinates, rectangular coordinates would be 2 rad 3, comma 2. And that's our equivalent rectangular coordinates for the polar coordinates 4 and pi over 6. Now let's see if we can go the other way. So it says find the polar coordinates for each point with the given rectangular coordinates. So for this one, what we're given is an x equals 1 and a y equals 4. What we're trying to find is r and theta. So that's what we don't know. But we can figure out r from, if we did r equals square root of 1 squared plus 4 squared, we would get r equals square root of 1 plus 16, which is r equals the square root of 17. So we've got our r. To find our theta, we do inverse tangent. Theta equals inverse tangent of 4 over 1. So theta equals inverse tangent just of 4, which we just plug into our calculator. We get theta equals about 75.96 degrees. So to write this now in polar form, we would just do rad 17 and comma 75.96 degrees. So that's how you would switch from one to the other. Let's do another example. So this example says identify the graph of each rectangular equation, then write the equation in polar form. So this one, we are given the equation x minus 4 squared plus y squared equals 16. So just looking at that equation, we should remember from conics that this equation represents a circle, x squared plus y squared, those make circles, and this one has a radius of 4. We're looking at the square root of that value. value in order to come up with our radius, and it is centered at 4, 0. So we know that because our y didn't shift at all, this y value, it's not y plus or minus anything, and this x value shifted 4. It shifted 4 to the right. That's where we get. So we have a circle with a radius of 4 centered at 4, 0. We're going to try to write this in polar form. So the original equation we get is x minus 4 squared plus y squared equals 16. The next thing we're going to do is replace our x with our cosine theta and replace our y with our sine theta. So I've left this blank for you so that you can fill these in and take some time to actually make sure you can figure these out, but the equation is right here. So we fill in our cosine theta for our x, minus 4 of course, and that whole thing is squared, plus our sine theta, that was our y, and that's also squared, and equals 16. So we can actually multiply this out, we can FOIL this out, and we're going to get r squared cosine squared theta minus 8r cosine theta plus 16, that's just foiling that first term and combining like terms, plus r squared sine theta equals r squared sine squared theta equals 16. So next thing we can do is subtract r 16, or essentially combine our like terms. We get r squared cosine squared theta minus 8r cosine theta plus r squared sine squared theta equals 0. And now we can isolate our squared terms, so we can say r squared cosine squared theta plus r squared sine squared theta equals 8r cosine theta. So we have our squared terms all together on one side, and we have our 8r cosine theta on the other side. We're going to look and see why this is, but obviously at this point we're going to have some cosine squared plus a sine squared, which might be easier to deal with. So we can factor out an r squared from both of those terms to get that. We get r squared times cosine squared theta plus sine squared theta. You should see at this point how that's going to reduce pretty nicely. Again, getting cosine squared theta and sine squared theta together is always helpful because of that Pythagorean identity, which says cosine squared plus sine squared equals 1. So now we just have the equation r squared times 1, or just r squared, equals 8r cosine theta. We can divide both sides by r, and we get the equation r equals 8 cosine theta. We remember from the last lesson on graphs of polar coordinates that this means we have a circle whose radius is 4, whose diameter essentially is 8, and it looks like cosine, which means that it's reflected, that it has symmetry about that polar axis, and it looks something, if we put this out at 8, it looks something like that. Which means also this would be a radius of 4 if we were talking about rectangular coordinates. Oops. Radius of 4, and its center is over here at 4, 0. So we come up with the same equation, we have the same expectation, and that's how you do that.